Alrighty, today we are doing day one of our piecewise function notes. And what a piecewise function is it just means that our graph and our function are defined by more than one equation. So you will see each of those equations listed along with the domain over which you will use that particular equation. So for this first one, I have two equations in my function. And when I have x values less than 0, I am going to use the equation x squared plus 1. And when I have x values greater than or equal to 0, I'm going to use the equation x minus 2. So first we are just going to evaluate these algebraically. And when you're evaluating these, your first and foremost step is going to be deciding which equation do you use. So for A, if I want f of negative 4, that means x is negative 4. That is going to fall into x being less than 0, so I'm going to use the top equation. So that's going to be negative 4 squared plus 1, which, again, following order of operations, you're going to get 16 plus 1, which is 17. On B, f of 0, that means x is 0. That's going to fall into this bottom category where x is greater than or equal to 0. So that's going to be 0 minus 2. Which is negative 2. And then lastly, f of 10 plus f of negative 2. First, I need to find each of those individual values. So first, f of 10, for that one, I'm going to use the bottom equation because 10 is greater than 0. And that is going to be 8. For f of negative 2, I'm going to use my top equation because negative 2 is less than 0. And that is going to give me 5. So f of 10 plus f of negative 2 is equal to 8 plus 5, which is 13. Okay, on the next example, I have three equations for this function. The first one is when x is between 1 and 6. The middle one is when x is equal to 6. And the bottom one is when x is greater than 6. So for g of 9, that is going to fall into the bottom category when x is greater than 6. So I'm going to plug in 1/3 times 9 minus 8, which is going to give me negative 5. For the middle one, g of 6, when x is equal to 6, that just means y is 5. That one, no math involved. And then on the last one, g of negative 2, when x is negative 2, well, that is not included in the domain for this function. So that is going to be undefined. If you have an x value that's not in your domain, it is undefined. Okay, the next skill we're going to practice today on day one with piecewise functions is graphing. So when I am graphing a piecewise function, I find it is easiest to organize my thoughts by making an xy table for each equation. So this first one that we're doing has two equations, so I have two xy tables. And let's do negative x minus 2 first. Well, this one is starting at x values less than negative 1. So I'm going to put in negative 1 first, and I'm going to make a note to myself here that this needs to be an open circle. And that's because I don't have this inequality underlined, so that is going to be an open circle on my graph. And then a few other values that are less than negative 1, negative 2, negative 3. You don't have to fill in the table every time, but you just need to have enough values to be able to see what's happening and plot enough points. Now I need to fill in my y values. So again, negative 1, if I plug that in here, that's going to be a negative times negative 1, so that becomes positive. Positive 1 minus 2 is negative 1. If I plug in negative 2 here, I get 0. Negative 3 gives me 1, negative 4 gives me 2, negative 5 gives me 3, and on and on. So I'm going to plot a few of these points now, making sure, again, at negative 1, I have an open circle. And then I can go on and plot these other points on my graph. And they are going to go off forever, so I need to make sure that when I connect these dots, I have an arrow indicating that it keeps going. Okay, and the next one is just going to be that y is equal to 2, but my x values start at 2 and increase. Again, this one is going to be an open circle because my inequality is not underlined. Here are some other x coordinates that are bigger than 2. And for all of these, y is going to be 2. It's going to be a horizontal line. So I need to put my open circle here, plot a few other points, and just know that this keeps going forever. And so I'm going to indicate that with an arrow. Okay, one more example of graphing these piecewise functions. On this one, I have 3 equations, so I have 3 tables, again, one for each. I'm going to start with x plus 6, and this one has 2 distinct boundaries, -5 to 0, so I can only use numbers between -5 and 0 here. And at -5 and 0, both of those are going to be open circles because both of those do not have an underline. They're not included. So again, plugging them in here, -5 plus 6 is 1, -4 plus 6 is 2, 3, 4, 5, and 6. So I'm going to plot all of those points, making sure to include my open circles where they belong. And connect the dots. My second one at -2, this is only when x is 0 and y is -2, so that's just going to be one closed circle on my graph at that point. The last one, x is between 0 and -6, so I am only going to use values between 0 and -6. The 0, again, has an open circle, but the 6 is closed. And for all of these, my y coordinate is the same. I don't have to do any math. And I can go ahead and plot all of these points. Now, what is different from this graph to the first one we did is that these intervals have distinct start and stop points. They don't go off to infinity, so I don't have arrows. Okay. On the first one, again, they were going off forever, so we had to make sure we had the arrows. On this one, we had distinct start and stop points. So what I want to do is pull up an example from your homework so that you have an idea on how to approach that. So here's a great example on how you would need to do that. So if I'm given this piecewise function, again, I have 3 portions and they all need to go on the graph. Well, this first one, again, for x values where x is less than or equal to -1, that means that this is going to be going off forever. So this is not an exact way to graph this one, but for example, what I would need to do is drag 2 points along my graph. Like I know, okay, it's at these 2 points. I know this is a closed circle, so I'm going to leave it alone, but I need this to go off to infinity. I would click twice, and it changes it to an arrow. Okay, for my middle portion, I'm going to have 2 open circles. So from there, again, this is not the exact line. I'm just demonstrating for the intervals and how to do the circles and arrows. Both of these need to be open, so I would click them both once. And then again, for this last one, that one's also going off to infinity, so I would need to make sure to switch that to an arrow. So if you only needed to graph 1 point, you would, along here, just click close circle and plot it where you needed it. But when you're working with your lines, again, clicking on them changes them from closed, open to arrows. So that's just some helpful tips on how to graph these in Delta Math. And that wraps up our day 1 of Piecewise Functions.